A skateboard with giant, like, tires. No. The wheels are like this big, and they're rubber, and they're inflated, and you have a brake. So picture like a skateboard about the size of a snowboard, a little bit smaller, but like up on these big rubber tires with feet grips, like your feet go in it, and you have a brake handle. So you can like go off-road and everything, and jump over stuff, and look up like mountain boarding videos on YouTube. It's pretty ridiculous. I have a longboard in my garage actually. My friend gave it to me for free. I have a lot of toys. This is why I don't have any kids. I have too many toys. All right. So today's lesson is a third of yesterday. I mean that mathematically, not like it's a third of the length. Literally everything we're doing today is a third of what we did yesterday. That's it. If you know that, you're good. Mathematics, I'm not trying to make a pun. Literally, today is just a third of yesterday. That's the only change, is 1/3. So 1/3 big B times H for the pyramid, and 1/3 big B times H for the cylinder. Or if you want the whole formula, we have our pi r squared for the big B. And then, of course, H has to be the vertical height from the center up to the very top. Any questions on our formulas? So the Louvre in France is a very famous museum. I would like to go there sometime if I ever get to Europe. It is a square pyramid. The museum actually goes down underground. So this is like a big, like central kind of beautiful area. But a lot of the stuff is sub-ground level. So if the height is 21.64 meters, which, think about that on itself, that's over 60 feet tall. This pyramid is like the size of a 6-story building. What's the approximate volume? The other thing we see, and I don't know if you can see it very well in your print image, is that, ooh, that's so off. This edge right here is 35.4 meters. So while I recalibrate this really quick, go ahead and try to find your base area. Then we're going to multiply it by your height and divide it by 3, and that will find our volume. So we know that in a square, my area formula is just the edge length squared, or side squared, depending on how you want to reference it. So our side length here for the square is 35.4. So when we square that, we get a value of a little over 900, probably over 1,000 actually.
1,253.16.
Wow, that's not creepy or anything.
That was actually good.
You sound like the Daleks. So then,
Oh, Mr. Hudson.
I don't have much time to watch TV, but I do quite like Doctor Who. It's a great show. Blink kind of made me not sleep for a few nights, but not really. But it's quite creepy. Like, I don't get scared by like scary, stabby, gory, bloody. I get scared by like in your head scared.
Yeah, that kind of scary.
So we have our base area. Here's the trick about the process. You can do your 1/3 whenever you want to, because multiplication is a commutative process. It doesn't matter the order. So I could take this value and divide it by 3 before moving on. Or I can multiply it by the height and then divide by 3. Or I could take the height and divide it by 3 before I do the multiplication. It doesn't matter when you do it. If I just apply the formula, though, 1/3 my 1253.16 times my height of 21.64, and we get a final volume of
9,039.4608. Oh, okay, I got that.
It's like an accuracy war.
What's the approximate?
And neither of you said meters cubed. So.
Meters cubed. I wrote it down though.
Do you have it written down, Calvin? All right.
What is the approximate volume?
Oh, so we would not need all those decimal values. If they're asking for approximate, we could say that approximately it's 9,040. Yeah. Like if we wanted to round. So when they're talking approximates, they want nice, easy numbers to work with.
Wouldn't it just be 9,000?
Yeah, we could honestly, depending on how accurate we were trying to be, we could say roughly 9,000. Or you could say just over 9,000. And that would communicate to people, okay, it's a little over 9,000. Who cares about the extra? Kind of that sort of thing. So we also have, and guys, there are a lot of like really cool structures around the globe.
The pyramids.
Yeah. So the Great Pyramids in Egypt. So a sports arena is shaped like a pyramid. I don't think this is actually
Sports
real.
arena?
That would be sweet though. Think about it.
That would be cool.
Like all the cameras and stuff could be up in the peak, like the drone type cameras and stuff. Like it would be a cool design.
Oh, and if it had like the, I forget what it's called.
Or it could like open up at the
You
top
wouldn't be able to hold
if
many
they wanted to
people.
like have it be
it
open
wouldn't be
air.
able to hold that many people.
Because you just have one level and it wouldn't be able to hold people.
Well, no.
Unless
Your
it is
issue would be that
flat.
your base would have to be extremely wide. Because as your roof comes up like this, you know, like,
Right.
so you would need
Well,
like
it would be
concessions
like
and
this.
parking or something around the
Oh, yeah.
No,
outside.
but then your like seats would have to angle in like that.
Yeah.
Would be weird.
Because
That would
if
be
we-
so cool, and then you could look down and no one would ever block your
Because
view
instead
you
of
always
going
just
up
go
like
That'd
this,
be
that'd
yeah,
be
it would get
scary.
cut off, right? So that's the only
You
issue.
can make it an upside down pyramid.
You could just have like a glass.
I
That'd
was
be
saying
really
you could go like this and then.
You could just have
Yeah,
like a
because
glass
Calvin,
floor.
how would it like hold?
That'd be sweet.
You could
Okay,
so
I love how far we want to hypothesize this, but let's refocus.
Oh, we're not.
braces and then upside.
We're told the base area of 300,000 square feet. We're told the height of 321 feet. Here's the nice part about it not mattering when you divide by 3. Take your big B and go ahead and divide it by 3.
100,000.
So then we have 100,000 times my height of 321. So really, my volume is going to be that 100,000 since we already applied the 1/3. I have a handheld sharpener that's normally better than that.
And I did it the wrong way.
It eats most pencils.
I found that it was bad.
Or you can borrow one of mine if you need.
Okay.
Times the height of 321, and we will get
32,100,000 feet cubed.
I had that.
Ah,
I
he
wrote down
got
feet cubed, though.
you.
I wrote down
Buddy
feet.
said it.
Oh no. I had it.
That was short people.
Now, if we are given the image,
But if it's the approximate value, it's just 32 million.
Just
okay.
feet cube though.
Feet cubed.
Feet cubed. Stop trying to come back.
So, and part of the reason why they're saying approximate is like the Louvre, that measurement they gave us may not be precise. So when we're working with measurements that are like so many meters or something, like that may not be the exact measurement. So that's why we often will say it's approximately. That protects us as opposed to saying it's precisely, because then you have to be accurate. So that's why we're using approximate. So now we're given the image. Again, we're told it's a square-based pyramid. Who can talk me through this? Yeah, Michelle?
So, first you have to find the height, and you can, so if you drop a height, it'll make a right triangle with the slant height and the base. And so the one leg is 20, and then you can use the Pythagorean to solve. And then you get that the leg x height thing is 15.
Do you see it?
It's also a 3, 4, 5.
It's a 3, 4, 5. Now, the only dangerous part with that is could the height be the long side? Like, so this one is a 3, 4, 5, but could we, when we saw the 20 and 25, immediately assume that? So that's the dangerous part. So you can think, oh, this is a 3, 4, 5, but check it with the Pythagorean. So then we've got our 15. So
If
now
you check it, is it?
yeah, I mean, Michelle did it with the Pythagorean. So.
Oh, okay.
And then when you multiply the 15 and 40 times 40 and then divide that by 3, you get 8,000 feet cubed.
So we did 40 squared here for the base area, and that gave me, 1,600. So then to plug in, it's easiest to 1/3 my 15, so that's why I'm changing the order. So this would be 5 times 1,600, which you said again, was?
8,000 feet cubed.
I agree. She's right.
What?
She's right.
Why does the 8,000 get the comma treatment, but the
What, the 1,600? Because it was a working number. Sorry, sometimes my working numbers miss out on their commas or decimals, but my final values I normally try to write correct. So there, I would need a decimal too.
Why can't you assume 3, 4, 5?
So this is a question I wanted to pose to you, and like I didn't know if people were gonna grab onto it to check. So we know a leg and a hypotenuse. The question I'm posing is, can we immediately assume the leg we see is the long leg? So what you need to think about is, so here, if this, what the only way this wouldn't be a 3, 4, 5 is if this was somehow a leg greater than 20. If the height was more than...
But that would make the 25 longer.
Exactly.
No, it
So,
wouldn't. It's still right triangle.
With those two numbers.
Right.
so if this was greater than 20, and you had, so let's say this was 21, and this is still 25. What would that mean about your third side?
It wouldn't be 20.
Yeah, it can't be 20. But, so that's what I was trying to get you to reason through. When we see 25 and 20, can we assume it's 3, 4, 5? Yes, we're allowed to go straight there, because if I see 25 and 20, that 20's got to be the long leg, assuming it's a right triangle. So we are actually allowed, anytime you see, a multiple, but that's not the word I'm looking for. Anytime you find a triangle similar to 3, 4, 5, any multiples of it, you can make that assumption. If you've got your hypotenuse and your long leg, you can jump right there.
Because there's only one value that the
Exactly.
other leg can be.
There's one option. So we don't need to use the Pythagorean theorem, is what I was trying to get to, is you can just 3, 4, 5 it. And on the back. This is what's interesting about how you guys told me to skip this chapter the first time around. I feel like it's real easy. Like, I feel like you guys are having an easy time with it. So again, we need to solve our height. So you guys solve your height, then solve out all the way for your volume. Hang on to it, Michelle. Make sure that you can tell me all the pieces parts.
I can tell you all the pieces parts.
Nice.
Every last one.
All right, Brian. Well, let's start then. We'll work kind of slowly to let everyone else have time.
Alright, so you have to use the Pythagorean theorem for the 13 and then the 12 because it's in the middle.
Yep. You do your difference of squares, and you found out the height was.
5.
And then.
You just get the square of 24, which is 2,880. And you multiply that by 5.
If you want to see a cool, when we go back to foiling things, by the way, with like squaring numbers like this, just because we stopped here for a second, because I did. If you made 24 a binomial and look at squaring that, remind me when we go back to FOIL to look at when these are like terms. I know that we could, what? I didn't do this. Brian gave me this number.
No, Brian.
What I did? Oh, wait, hold on.
See, that's what I was
got
about to check.
576.
Okay, good.
So,
That was after I multiplied it by 5.
I was so worried.
here's the thing. If you have to do this manually, you can make it easier on yourself by making your 24 a binomial and multiplying it by itself. So then you could first, 20 times 20 gives you 400. Outside, inside will double, so you'll get 80 twice. And then your lasts will give you 16, and you could add all those up. 400 plus 2 80s gives you 560, plus another 16. Because the thing I didn't write, I saw your face, is this 20 times 4 gives you another 80.
Yeah.
If you have to square really big things and you don't want to set up the stacked multiplication and do all that, you can use FOIL, which honestly, once you're comfortable with it, is a really easy process. Yeah.
And you can use something derived from FOIL to multiply any
What do you mean?
polynomial, right? You just multiply everything times everything.
Everything times everything. What do you mean? When you're squaring things, or?
Well, like not just binomials. Like,
Oh, yeah, it's just distributive multiplication. The only reason that FOIL is specific is it's binomial times binomial, but what you're talking about is like a trinomial times a binomial, right?
but you could use a similar strategy.
It's the same so I would take my first times both, then my second times both, like individually, then my third times both individually. It'd just be a really weird, I don't know what we could name that, because it wouldn't...
It's like combinatorics?
That's slightly different. That deals with ordering things and how many different permutations and things we can have.
What's the one that isn't permutations?
I mean, there's combinations and permutations, but...
It's every combination of...
Oh, because you could multiply different... Yeah. And you can break the numbers up any way you want. Yeah, but we're going too deep, because we can also just use a calculator. But we have our base, 576. I want you to understand how to do it for the when you don't have a calculator. But for right now, obviously, we can use a calculator.
So I skipped a step. I went to my number after I multiplied that by 5 instead of that number.
So this times your 5 then
is 2,880. And then you have to multiply that by a third to get 960 meters squared. Cube.
Any questions?
Is that how you spell TP?
Yeah.
I always thought it was TIPI.
That'd be TIPI. So TP literally, but this to me looks like TEPI because I used to actually write it TEEPEE, like TP, but I don't know. So apparently this is how you spell it. It's 12 feet high with a base diameter of 14. Base diameter of 14. If we want to find the volume of this, which would be very important for knowing, like if you were trying to smoke meats or leather or different things, you want to know what the volume is so you can use the right amount of wood. I'm not making this stuff up. You care about the volume of a smokehouse or whatever people call it because they literally, like, Native Americans would smoke meat so that it wouldn't go bad. That's really the point of smoking meat. It cures it, it kind of cooks it. So you would use a teepee or whatever as a smokehouse.
Would this make it as big as they needed? You don't have to calculate this.
So like if I put too much wood in the fire in the smokehouse, it'll either have too much fire or way too much smoke, and then if there's too much smoke, the fire can't burn. And if there's not enough wood, then it burns out and it doesn't get the right amount of smoke and my meat goes bad. So like there is a ratio, not that they would sit around and calculate it, but I'm sure they had people who figured it out. This TP needs this much wood. They weren't calculating mathematical formulas, but essentially it was a proportional relationship.
Okay.
So all we care about is let's calculate the volume. I'm trying to relate this to real life, why we care. So we have a third times our base area, which is going to be the area of our circle times the height. Let's deal with base area first. How do I find the area of this circle, Carmen?
Pi r squared
Pi r squared. And my
so
radius here
is 7. And
is 7.
squared is 49.
So we get 49 pi. If we leave it in terms of pi for the moment, just because I don't like decimal values carrying through the whole problem. So a third. Now we could, can 49 easily divide by 3?
Mm-hmm.
No. No.
But 12 can't.
45 does. 48 does. So I can't do a third of my 49 pi easily at least, but my height of 12. So now, make your life easy, do your third of 12, and really the math you're doing is 4 times 49 pi. 4 times 40 would be 160, times 9 is 36, 196.
Or 614.8 feet cubed.
614?
615. Yeah,
It's
what?
615.7521601.
Yeah.
That's what I got.
You might have rounded before.
Did you do like the actual pi? Did you do 3.14?
No, I must have just typed in like 190. Probably just wrote it wrong.
Yeah, always make sure that you're using pi button, because as we get larger values, having that accuracy in pi will matter.
Pi button.
The pi button.
Found it.
Wait,
You know, the
have
button-
you never used the pi button?
The button that, you know, gives you pi immediately.
I wish.
Dude, I would
Gives
love
you endless pi.
That would actually
That'd be
take.
great.
Like, you didn't-
So, solve the got it for a child's play TP. Let's compare that volume. You know, like that TP from Target.
Are you
Oh.
sleepy in the TV?
They have it.
That's just called the outdoor.
And I
I
also
figured.
have all the rest.
Me too, honestly.
Just so I know that you know what you're doing. It's just kind of a basic school thing. This is also why I gave you guys all of your homeworks. If you want to work ahead and solve through everything and get done with stuff, you're more than welcome to.
You should let us listen to music during tests.
You should.
Your own music.
Our own music. With
Write
lyrics.
me an argument with data collected by actual researchers from unbiased sources, and I will entertain the request.
Brian.
How long does this thing have to be?
You also must have all of your class materials every day.
Every day.
Well, I mean that you.
Like
you're
one
gonna
day
have
and
to
it's
have
gone.
Stuff, otherwise
One
you go
day.
to the office. So.
Yeah. So you want me to change my policies, yet you can barely remember to bring your crap to class. So I'm not very encouraged to change my policy when you can't remember a pencil.
I have a pencil.
Yeah, now, because I've been harping on you forever.
I have
It's
a
been like
question.
18 weeks.
Oh my gosh.
Yeah,
Little-
you're
little-
right. It's been like 16 weeks, honestly.
Little less.
Stravel.
Do you need a bucket of water? Because right now you're flaming him.
I thought you were going to say I'm like crying a river or something.
No, that's Brian.
Yeah. Wait,
What's up,
Brian
Jake?
right
Why
now.
would you
Miss
get something
Rosie's
for,
flaming you.
Is that okay?
Yeah, no, you can take any of these kids. They're great.
Why would you need a bucket?
They don't even really need me. I just kind of hang out with them.
That doesn't make any sense.
Yeah, I'm confused.
You need an empty bucket.
Can anyone walk me through all the way? Rhea?
Okay, so should I do the? Okay, never mind. Okay.
You can just give me everything real quick. Like, so what was your base area?
24.5. Wait, never mind. I skipped that.
So we got to do 3.5 squared.
Yeah. And then
Times
pi.
Wait. We are on probably 4.
Yeah, the child's TP.
Oh, sorry, we did go. Never mind, sorry.
12.25.
Yeah, 12.25. And then I multiplied it by the height, which is 6. And
Now here's where I'm going to disagree with you slightly. Not because it's better or differently, but if I were solving this, I would just go ahead because it's less to type in the calculator.
That's right, did I just?
Yeah, just do that mentally, because then all we have to type in is 2 times my 12.25 pi, which really, we should be able to figure this out in our head. We have 24.5 pi, which gets,
24.5 pi.
and because I went it to the nearest cubic foot, what is my decimal value?
76.
Feet cubed. My level
969
Calvin.
Brian.
Questions? Now, this is what I was talking about a little while, like a couple weeks ago, where I was referencing you can take the top of a cone and move it around and it doesn't actually change how much space is inside of it. So this cone right here is an example of that. So we call this an oblique cone because it is not symmetrical on the sides. So still our formula is exactly the same. You can play around in GeoGebra if you want and see how changing that vertex point, as long as it stays at the same height, will not change the volume inside of it. So we have a diameter of 30. They tell us the radius is 15 and a height of 25. Anyone new want to walk me through this? Anyone who hasn't had fun today yet? We've talked. Brian, I'm
Okay.
being mean to you.
Just come.
Okay, so
You're flaming.
you have to do the whole pi squared shenanigans.
So when we find our big B, what's our radius?
I haven't calculated.
What's our radius?
Oh, it's 15.
What's 15 squared? This might be that one in your head.
I haven't calculated
225.
it yet. Jump around that.
So then,
It's 35.
And you would multiply that by 25.
225 pi.
Yeah, do that.
yeah.
Alright, so then you multiply that by 25, because that's the height. and then you get a third of that, which is
1875 pi.
yeah, and then you multiply by pi.
No, it's
Is it not
No,
that?
you don't
Oh.
multiply by pi. If you want to,
oh
I don't know.
And also rounded.
Okay, then
So we
you-
get 1875 pi.
That's 5,890.486,225
Well, it says nearest.
feet
So
squared cubed.
feet squared cube.
Squared.
So feet to the 6th power.
You didn't add your units
I
to
got
the
that.
pi.
Vince.
Oh, never mind, never mind.
Sorry, I have my units out here. So. And Triley got it, and we will wrap up.
Yeah.
Was it mirrored in this lesson feel extremely quick?
That's why I said it's the same as yesterday, just divide by 3. Like, it's not new content, it's just new application.
Right.
And as long as we can agree on a volume, I don't even need any of the work. Just want to make sure that you guys have it solved on your paper. Ethan, you already got this?
yes.
What'd you get?
452 meters squared.
What'd you get in pi also? Because they want it in pi.
144 pi meters cubed. Yep.
And then,
I
as a
got that
decimal,
too.
that
I got
was
that too.
452 meters cubed.
I really.
Any preguntas?
No.
Hopefully you guys know that means questions. You've been in
Yeah.
Spanish long enough.
Well, we haven't learned
He
that.
didn't
actually-
teach us that, you did.
Would you like to move on into whatever it is, 8595, whatever?
Oh, we're good.
I don't know if I have that.
I'm fine.
Oh, no!